All right, so you've built a circuit with an op-amp. You're expecting this beautiful, perfect signal to come out, and instead it just stops. It hits a wall. Well, in this explainer, we're going to dig into exactly why that happens.
Okay, so let's jump right in with what I like to call the saturation mystery. And trust me, if you haven't seen this in your own circuits yet, you will. It's pretty much a guarantee.
Yeah, so you're looking for that nice, clean, linear output, right? But what you get is a flat line. The signal just slams into a ceiling and stays there. It gets stuck. It won't go any higher, it won't go any lower. So what on earth is actually going on here? So this weird behavior isn't just some random glitch in the matrix. It actually has a name. We call it saturation. And look, getting a handle on this is so important, whether you're cramming for an exam or, trying to build something that actually works out in the real world. All right, let's get to the real heart of the matter. Why does this even happen? Well, it all boils down to this classic fight between the perfect, clean world of theory and the messy, limited reality of the physical world. So here's the fundamental problem. On paper, in theory, an ideal op-amp has infinite gain. That means it can take the tiniest little difference at the input and multiply it by a bazillion. But back in the real world, that op-amp can't just create energy out of thin air. It has to be plugged into something, right? It's powered by a limited, finite voltage supply, like the plus and minus 15 volts you often see. And that right there brings us to the golden rule, the single most important thing to get from all of this. An op-amp's output can never, and I mean never, exceed the power supply voltages you're feeding it. Those are its rails. It's a hard physical limit. End of story. Okay, to really make this idea of a physical limit click, let's use a really simple analogy from everyday life. It helps a ton.
So just forget about op-amps and volts for a second. Imagine you're driving a car. Now, that car, it has a top speed, right? Let's say it's 100 miles per hour. No matter what, it physically cannot go faster than that. That's its limit.
You can stomp on the gas pedal, push it all the way to the floor, but that car is not going to hit 120. It's just going to stay maxed out, pegged at 100. The engine is screaming, giving it everything it has, but it just can't break that physical barrier. Well, an op-amp does the exact same thing, but with voltage. It hits its power supply rail, that's its top speed, and it just stays there. That's it. It's saturated. Okay, so we've got the why down. Now let's talk about the when. What are the common scenarios that actually push an op-amp into saturation? The stuff you'll see in the lab or for sure on an exam. So, what are the red flags to watch out for? Well, saturation usually pops up when there's no feedback loop to keep things in check. Or maybe the difference between your input signals is just way too big. Or the gain of the circuit is set to some crazy high number. Any of these things is basically asking the op-amp to produce an output voltage that's just impossible for it to deliver. And this, by the way, is exactly why negative feedback is our best friend in circuit design. Think of it as the control system that we build in to stop this from happening. By taking a little piece of the output and feeding it back to the input, the circuit is constantly correcting itself. It's what tames that insane theoretical gain and keeps the output stable, right in that useful linear zone, and safely away from those saturation limits. So, this all brings us to the final, most important takeaway. If you only remember one thing from this whole explainer, let it be this. See, op-amps don't saturate because they want to or because they're broken. They saturate because they have to. It's a fundamental consequence of physics. The op-amp is always trying its best to do the math, but at the end of the day, it's trapped by the limits of the power you give it. So keep this in mind, whether you're prepping for your GATE exams, hitting the books for semester finals, or you find yourself in a technical interview. Getting a solid grip on saturation isn't just about scoring points on a test. It's about really understanding that crucial line between the perfect world of theory and the real world of electronics you'll be working in.